Yeah, maximum number of events that can be attended. Okay, so I already tried this problem once, so let's let me try it again. So we are having n events in a geek city, and you are given two arrays, start and end, denoting starting and ending day of the events respectively. Event I starts at start I and ends at end of I. You can attend an event I any day d between start I and end I. Okay, so if the day is between start and end, like we will be able to attend. But you can attend only one event in a day. Find the max number. Okay. So the first one, so the start I denoting the starting. So there is an event that is starting at day one and ending at day one. So okay, we can attend that. And there is another event that is starting at day 2 ending at day 2, so it's not conflicting with the first event, so we can also attend that. Now there is another event which is starting at 1 ending at day 1 but ending at day 2, but we already attended another event that started with 1 and ended at day 1. So it's basically if we consider a line here. Okay, this is 1 2 3 4 5, just a number line, and we are having an event that started day 1 and ended day 1. We are having another event that started day 2 and ended day 2. We are having another event that started day 1 and ended day 2. Okay, so we can attend this event which starts at day 1 and end at day 1. We can also attend this one. We start at day 1, day 2 and end at day 2. But there is an event which is starting at day 1 and ending at day 2, but we cannot attend because we already attended at day 1. So in a day, like we are only able to attend one event. And also in day 2 we already attended one event and we cannot attend any other event. So that's what the problem is asking, like by keeping in mind like we can only attend one event at a particular day, how many event it's possible, how many event, like the maximum number of events which is possible for us to uh, attend. And the next one is we let's also, so there is one event that is happening at day 2, day 1 and ended day 2, we can attend that. There is another event which is starting at day 2 and ending at day 3, it's also possible, like we are not conflicting it. And there is another one starting at day 3 and ending at day 4. So if we can consider the same. Okay, 1 2 3 4, there is one event that is starting at day 1 ending at day 2. There is another event that is starting at day 2 ending at day 3. There is another event that is starting at day 3 and ending at day 4. So all these can be attended, there is no problem in attending all this. So the logic that we need to apply here is we need to um, sort based on the start time. Like we can have a pair here. So in Java, like we can create a class pair which is containing the start time and start day and end day, and we can just make use of or create an array of this pair and just sort based on the start time. So here after sorting based on the start time, let me take that example. So if we sort based on we are having 1 1 2 2 3 1 2 1 2. Okay, now if we wish to sort it based on the start time, like we will be having a pair 1 1, we will be having a pair 1 comma 1, then the next one will be 1 comma 2, and the next one will be 2 comma 2. So we just need to find like, so the one thing is like in a day we are only able to attend one single event. In another day, in the same day, like if there is any other event happening, we cannot attend that event. So the idea is we need to keep track of the ending time also, like which event is opening, event is opened, and which one will be closed. So for that, like a priority queue will be the best. So we can have a priority queue, a min heap. Okay, so here what we'll be doing means, like we go through our pair and we just check. One consideration is like, here our day will be from 1 to 10 raised to 5. So we will be just traversing from 1 to 10 raised to 5 here. And in day 1, we just take the day 1. In day 1, like we will be tracking what are the events that we can attend. So in day 1, like we can attend 1. So we'll be storing the end time. So we'll be storing this one in day 1. Whether we can attend any other event, we can attend this one, but this is having an end time of 2 and there is no other event. Okay, now in this, like while the priority queue is not empty, like we will be checking, we will be taking the topmost element, we will be checking whether it is less than the day, whether it is less than the day. It is not less than the day, so no problem. We just check this one, whether 2 is less than 1. 2 is not less than 1. Okay, so if the priority key is not empty, what we will be doing means we just be putting we just be having a count in order to count the number of elements, and we will be having a count 1, and we will be popping this element out. Now we have the day 2. So this to have the day 2, so there is one event that is still opened and it will be ending at day 2. Now we will be just checking whether which of this is having a start day of 2. This is not having a start day of 2. This is not having a start day of 2. This is having a start day. So we will be putting the end day into the queue. We put the end day into the queue. Now we will be traversing this queue. We will be checking whether the top of the queue is less than the day. The top of the queue is not less than day. If it was less than day, like we will be just popping the element. So here nothing is like, so we just say like this event is finished. Okay, that event is finished, so there is one more event that the person was able to attend. So we are done. Now day 3, day 4, no need to consider because the priority queue will be always be empty. Okay, so let me try to implement this. So first of all, I will be having a class pair, and it will be having start day, end day, and I can have the constructor int start day comma int end day. As a best practice, like we can have this private fields and have the getters for the start day and end day, and for the current case, like I am not going with the getters and setters, like we can just directly access using like the object dot, like that method. So this dot start day equal to start day, this dot end day is equal to end day. Okay, so the first thing that I mentioned was not to have an array of this pair. Okay, so we can have an array of pair start end day, which is equal to new pair of size n. Now we can populate this array for int I is equal to 0 and less than n, I plus plus, start int day of I is equal to new pair of start of I comma end of I. So okay, now we need to keep track of which of the elements are open or which of the events are opened. We also need to close the event, so we can have a priority queue of integer. Let's call it min heap because we are making use of a minimum heap. Priority queue. Why minimum heap means like we need the closest day. Every time like we are looking for the closest day, which the closest event that we can attend. So we need the smallest elements into the top of the queue, top of the priority queue, so min heap. So that's why like we are making use of min heap. So now for int day is equal to 1, day is less than or equal to 10 raised to 5, 1 2 3 4 5, yeah, day plus plus. Now while we need to have one index, this index will be used to traverse through our pair array. Now we need to have max event attended in order to keep track, and this is the thing that we are returning at the very end. So while our index is less than n, and then start end day of I dot start day is equal to day. If it is equal to day, then we can just put it at the end day into the priority queue, like we are attending it. Like not attending, like that event is open, like it started, that event have started. So min heap dot offer of start end day of I dot end day. Fine. Now sorry, it's not I, index. Now we need to implement the index, we need to go with the other elements also. Now while not min heap dot is empty, and then min heap dot peak is less than the day, which means like this event is closed, like we are closing it. So min heap dot pull. Now if not min heap dot is empty, if it is not empty, like we will be able to attend that event. So max event attend plus equal to 1, and we can just increment or not increment, we can just take out that element like that. Event is closed, that event is closed. Now we are able to, we are ready to take up any other event. So here we are making use of an extra array here. There's also a priority queue, so this can hold a maximum of n elements only. So the space complexity is big of n, and we are also making use of a sort. Sorry, I didn't sort it here, we need to sort it. That's the main part, one of the main part. Start end day, and we are sorting it based on the end start date. So we will be getting pair 1, pair 2, and I can have a compare. This is the easiest, one of the easiest method how we can let's say like apply the comparator, like sort. So integer dot compare based on start day, pair 2 dot start day. Okay, I think we are good. Let's check. So the time complexity will be big of n log n. We are having a compilation error. It's start day. I'm missing. Okay, let me just bring it down. Okay. I get 2. Let's submit. Yeah, it's running good, and we are good. So that's all. So the main idea, like we need to first sort it based on the start time. Now we need to go through like in which days like we can attend, in which all days like we are having a event, and we will be tracking that. We will be tracking its end when it will be closed, and we'll be just finding like which are the events, which are the closest event that we'll be able to find, which we are able to attend, and that can be achieved by making use of the priority queue here. So yeah, thank you.